Next up, we have student researchers from Buffalo-Niagara, New York, a Mission 9 flight experiment.
Hi, my name is Shanila, and this is Toriana. We were co-investigators for the experiment Supergrowth and Microgravity. Unfortunately, our primary investigator, Gabriela Melendez, couldn't be here due to family obligations. We are from Buffalo, New York. Our teacher facilitator is Andrew Franz. Our advisors are Dr. James O'Berry, Dr. Mary Besson, Christopher Murray, Kimberly Farr, Jonathan Plevin from University at Buffalo.
Our question is, will potatoes that have traveled in microgravity grow when planted on Earth? If one day the Earth were to become barren, then we will have to grow crops on other planets. Additionally, this work could be beneficial because there is a food shortage on Earth. Growing on other planets could solve this problem. If we wanted to explore more of our solar system, agricultural planetary stations could be leaping paths to further exploration. Our experiment is a baby step to this journey. Potatoes on the ISS will grow in an experimental nanorex tube in the UV greenhouse back on Earth, but not as well as the ground control.
This is our experimental design. It includes a 1.5 inch and smaller upstate abundant Solanum tuberosum, aka potatoes. 11 traveled to space, and we had a control of 10. Later, we added a second control group that wasn't originally in a tube due to sudden sprouting and lack of sample size due to potato-boring worm infestation. Our analysis includes a growth comparison over time, a starch assay, a photosynthesis comparison. This chart shows that from the time a potato sprouted, differences in growth rate are trivial. Our second control, the control not in the tube, grew slightly faster than our experimental and control group. However, our tallest plant, called Space 4, sprouted early and survived the worm infestation and is currently over 2 feet tall.
A starch assay tests for starch content. Starches are carbohydrates which we turn into glucose, and glucose is turned into energy. We wanted to find out if space travel affected the nutritional value. We found out that our sample size did not find a significant correlation between space travel and abnormal starch production. We were able to use a fairly new piece of technology to test the light absorbed by a plant leaf, aka photosynthesis. We were advised that the most relatable comparison that the multi-spec device made was between relative chlorophyll. According to our data, differences were negligible.
To conclude, there weren't many differences between either control or space potatoes when it came to starch content, growth rate, and light absorption. However, we would like to see this done again with larger potatoes, larger tubes, larger sample size, and perhaps with Matt Damon.
We would like to give a special thanks to Michelle Kavanaugh, Board Member Sharon Belton-Cotman, and Congressman Brian Higgins. Also, thanks to our additional sponsors. There are too many to name, but we are glad to and thankful for the opportunity.
One last thing before we end is that, as far as we know, this is the first potato whose parents traveled in space. Well, because since we had 2 control groups, and one was in the tube and one wasn't, the one in the tube was more compact, so it didn't really have that much space to move. And so, since, of course, microgravity played a big role in it, but there wouldn't really be that much of a difference. Thank you.